Let's do problem 5 now in module 3. Problem 5 is a problem where we're trying to create a confidence interval to answer a question. You have determined a sample proportion of individuals that have purchased some sort of offering in their loyalty program over 30 days. And this group is a group of millennials, so you've focused on a particular group. Your marketing officer claims that there is little difference in millennials and baby boomers in their participation rate. 25% for the sample that we'll see here with the millennials, and baby boomers have a 37.5% participation rate in the last 30 days. So the last 30 days, 37.5% of baby boomers use their loyalty program, and only 25, at least in this sample. So you want to ask the question, a serious statistical question: is there a difference between millennials and baby boomers? If we create a confidence interval about the mean that we've calculated in our sample for baby boomers of 25%, we'll get to that calculation in a second, and if the baby boomer value is included in that confidence interval, within that confidence interval, then we have to assume that they are no different. It's only after there is a value that falls outside of those limits that we can say that there's a significant difference in the differences between the millennials and the baby boomers. So let's go see how we calculated 0.25. Here are the people that have purchased. These are millennials from 1 to 40. There were 40 in our sample, and they either purchased or didn't purchase. So there's a no and a yes. And I've got to change that into a value that I can then use as a metric. If there is a no associated with this observation, then I'm going to use this if logic to create a 0, or if there's a yes, then I'll create logic, the same logic, to create a 1 in this column. And that'll allow me to create a proportion for the entire 40%. What proportion of the 40% participated? So here's our function, our if function. If what's in this cell is equal to yes, and give me a 1, otherwise give me a 0. So at the end, I calculate a proportion by taking the total sum of 1s and dividing it by our sample size 40, and here's our participation rate, and here's also a standard deviation for this data. And we'll need that also. So now let's return to our question. Let's create a 95% confidence interval about this sample. To do that, we can use the information that we got in our PowerPoint presentation on confidence intervals, and since this is a proportion, we can use this special formula for the calculation of the interval. Here is the value of our sample proportion. Here's 1 minus that value. Here is the sample size, 40. We take the square root of that and multiply that times this z value, because we're assuming normality here. Anytime you hear z, you're talking about a normal distribution, assumptions of normal distribution. So we have a z value of 1.96. We subtract that from our observed value in one case, and we add it to our observed value in the other case. There's a plus here. So here is the low end, here is the high end if you've done the calculation. We can also do this by using the confidence.norm function in Excel. We have to tell it what our alpha is, which is 0.05. We want a 95% confidence interval. We want to provide it with a standard deviation. We provide it with the standard deviation that we calculated for the sample, and we give it the value of the sample size, and we get very similar values here and here. A slight difference because the 196 here is rounded. So, is your boss correct? Yes, he's correct because the 0.375 is included inside this range for our sample. So there is no difference, at least at this point. This is very close, though. We might want to check it and see. We will see later how we do this very same problem with a hypothesis test. So that's the end of our confidence interval building problem 5 in Module 3.